This is probably what I have the biggest problem with. So we have a vector of a vector. It all comes down to one reason: memory. Hey, what's up guys, my name is Cherno. Welcome back to the code review series, the series in which I take a look at the projects that you send me. Today, we have this Windows Console Terminal Game Engine. I have never seen a terminal game engine before. Certainly not from a vet. Hi there, Cherno. I'm a 34 years old veterinary medicine doctor. I've been working on my own simple game engine which works in Windows Console Terminal. I'm trying to learn C++, so I've decided on this approach instead of working with OpenGL libraries. That is such a unique approach. I've decided on this approach instead of working with OpenGL. If you could give me feedback, I would really appreciate it. I packed the project with 2 games playable. You just need to set the craft shooter game or craft match as startup project to run. Thanks in advance. And this was, by the way, sent Christmas last year. So this was my Christmas present from this vet. Okay, here's a link to GitHub. Written in C++ will work in Linux and Windows. Let's just dive into Visual Studio and take a look at this project. So get this, I had so much to say about this main file that I actually made a separate video for it. I'll have it linked up there. Check it out. I think it's fairly basic and broadly applicable C++ advice. So definitely give that a watch if you're interested. And now let's get back to the rest of the code so that I don't spend this entire video just talking about one file, as I have a tendency to do. Okay, so looks like we actually have 3 games here: Craft Match, Craft Rogue, and Craft Shooter Game. And all of that is part of this thing called Console Craft Engine. So that's good. I mean, I'm already seeing a bit of a separation here between the engine and the games. Very important. And because this person's actually gone ahead and made 3 games, that reinforces the reason why this is important, right? Because this wouldn't really have worked if it was built into the game. So it's good to have that separation. I haven't looked at it too deeply, but I expect that so this actually builds into a DLL. That's interesting. I expected a static library. You know, I would always prefer a static library unless there's a specific reason why you want it to be dynamic, mostly because it's easier to deal with. It's just easier to use. But then also static libraries allow for more optimization, because since the code is all kind of present and apparent during compile time, during linkage, that is to say it's not loaded dynamically at runtime, it means the compiler linker can actually optimize the code that you're building, like using function inlining, for example. So, and then yeah, these are going to be EXCs. I noticed, by the way, that just inside, this is a very, very short side note, but inside this solution here, we have an actual Visual Studio solution. I didn't make this, right? This was included in the repository as well as what looks like a CMake lists file. So this looks like it full on supports CMake. I'm expecting it does that, you know, for Linux because this supports Windows and Linux, but then for Windows, it seems to use a Visual Studio solution. So I would probably not do that. I'd probably just use CMake for everything, because obviously if you ship it with a solution like this, I mean, I guess you could regenerate the solution before you commit it, but there's no reason to do that because obviously you can make the solution and the project files from the CMake. So I would stick to just CMake on all platforms in this case. Anyway, getting back to this. So we have 3 games. Let's play one of these. Whoa. Look at all those particles everywhere. That's crazy. I'm quite interested to see how this is put together. Look at this. I love the different colors. Destructive main scene. Just press any key to continue. I guess it closes it. That's funny. Where do I even begin with this code review? I should just get someone else to do it. Like AI. That's exactly where the sponsor of this video comes in, CodeRabbit AI. CodeRabbit is an AI code reviewer that can help accelerate the process of code reviews, leading to faster development and overall code quality improvement. There are lots of reasons why code reviews create friction for developers, and CodeRabbit aims to combat that using the power of AI in a natural way. And did I mention it's free forever for open source projects? Simply connect it to GitHub or GitLab, configure CodeRabbit to review your repositories, and then you can simply chat to it like you would with a human developer. CodeRabbit integrates into code repositories using GitHub or GitLab webhooks and monitors events related to pull request and merge request changes. You can try it out by starting your 7-day free trial, or you can use it for free for open source projects. Just go to coderabbit.ai, the link will be in the description below. Huge thank you to CodeRabbit for sponsoring this video. And then we finally call start game. The engine itself it looks like it's it's a class which holds a public vector of scenes, specifically scene pointers. Now, because the scene gets created in this scope and not deleted inside this scope, I'm assuming that the ownership semantics here are anything you put into a scene is now owned by the engine. It's now the engine's responsibility to delete it. And I'm sure that if we look at clean, for example, it's going to delete the current scene, but we have a vector of scenes. So what about the rest of them? What if I have more than one scene? So that looks like a memory leak to me. It's probably not that bad because again, these scenes technically, it looks like they live for the duration of the application. So it's not really a leak in the sense that it's going to accumulate more and more memory or cause any issues really. But if we did have multiple scenes here, then what happens is we set the current scene, which sets current scene equal to whatever pointer we pass in here. But then in the clean function, we only delete that current scene. So in this scenario, I have 3 scenes inside this vector. However, I'm only deleting one of them. How would we fix that? Well, you'd have to loop through this. So you'd go like for, how would I actually write this? Probably for scene in scenes, and then I would call delete scene. And I wouldn't bother deleting current scene. You know, you wouldn't need to because this is going to delete all of them. And then what I would do is I would call clear on the vector after this. The vector is still going to contain 3 pointers. The memory at the pointers has been freed. So they're basically invalid kind of pointers. So I would clear this just so that we don't like accidentally keep thinking that we have valid scenes inside this list. Now, the reason why I'm doing that as well is that because this is not the destructor. If this was the destructor, you could say this is not necessary for this to happen because the vector itself is going to be deleted in a minute. But because that's specifically a function that like maybe we want to clean and then restart a game or something, in that case, you know, we would want to treat this as a function that might run at any time, not necessarily at the end of Engine's lifetime. Okay, so for the start game, what do? We set the current scene to scene 0. So what happens if there are no scenes? What if we didn't push back a scene? Well, this would probably crash at some point because I think, yep. So we're going to call init on a scene, which we'll get to this in a minute. This wouldn't crash by itself, actually, if this was null, because C++ is not Java or C#, and it wouldn't give you a null reference or a null pointer exception. It would still call the function, but if the function, obviously that's not what we want anyway, because we should never be trying to initialize a null scene. But if the function then uses member variables, so data basically, that's supposed to be in this pointer or at this pointer's address, then obviously that wouldn't work and that would cause the crash. So it's like a indirect crash that would probably happen if this was null. But calling the function, interestingly, will not crash because it's technically okay to do it. It will just call this function with this keyword basically being null because there's no valid instance. Now, I think if, I might actually be wrong here, because I think I am wrong, because in this case though, generally I'd be right, but I'm wrong here, I think, because this class has a virtual init function. And in fact, it's just a virtual class in general. So to call init, it actually does have to look at the vtable. Now, this is null. So there is no vtable, so we can't jump to the right init function. So I'm pretty sure it would crash at the function call. So that's just something to be aware of. What happens if this is not the right state? This is something that we generally call defensive programming, where you're just putting in extra code to make sure that stuff is going correctly. And if it's not, you have the capability to recover if you so choose. Now, in this case, it doesn't really make sense for us to start up the game with no scene. If we're trying to enter a scene that doesn't exist, or if we're trying to, you know, set current scene here and that it doesn't exist, then it probably doesn't make sense for us to run anything, because if there are no scenes in this engine in the game, then we don't really need to do anything. So you could put in an assert. So if you have some kind of assert framework or just a normal C++ assert, if you must, then you can do something like, I'm just going to make sure that the size is greater than 0 here. And in that case, it would still run this code, but it would bring up an assert for you to be like, that's an invalid state. Alternatively, you could obviously check that. So instead of doing an assert, you could just be like, if, scene size, for example, equals 0, or in this case, you could just run empty as well. You could also check for not empty, by the way. Then you could just return and maybe print something to the console to be like, there are no scenes inside your game, just to maybe give some feedback to the person using this engine as to why nothing's happened, because they might be like, why is my game not running? And turns out they just forgot to add a scene. So these are the kind of things to think about, I think, when you're writing functions that use data specifically. So start game doesn't really have any almost prerequisites, but when you call a function with a parameter and when it accesses member variables. So current scene is a member variable, which again, it's not immediately apparent, which is why I love to use the m_ convention, because now I know that, okay, this is a member variable and this is a local variable inside this scope. When you're writing a function, always consider the inputs and the outputs. No outputs here because it's just void, doesn't return anything, but there is an input, it's seen. So what are the appropriate or acceptable states for that variable to be in? Like, is it allowed to be null, for example? If it's not, probably should do something here. Now in Hazel, which is a game engine that I'm making, for those of you who are unaware, we have asserts, we have verifies, we have macros for this kind of thing. So we would probably have something like HZ core verify. A verify is like an assert, but it also runs in release builds. It doesn't run in distribution builds, but it does run in release builds. And then we could basically just chuck in some code like this. And again, you can do this with a normal C++ assert. I like to make my own asserts because you can log it however you like. You can display message boxes if you want in certain cases. You can turn them off in certain builds really easily, like if you want it just in debug or just in release. So that's why I always advise doing something like this. If you have a decent library of code like an engine, it's very, very helpful. But regardless, it's very easy for me to just chuck in some code like this just to validate the state of this, because this is not allowed to be null. So it's not even a matter of I want to recover from that state. It's more of like we should not have gotten to this point. So if that's the case, I want to be aware of this like during development, and there's no reason to basically not have something like this, or at the very least an assert, which will only run in debug builds, because you switch that to release build and it's gone. That code gets stripped. So it's like we're not checking this. Whereas if you had something like if not seen, then error message or whatever, which is the same as checking for null pointer. Be very careful that you don't do this. But for checking for null pointer, then if we had this instead, then this would run at all times. So we'd have to either manually strip that out or wrap it in macros, which is basically what that assert or verify is doing. So this, by the way, is not a function. I should have mentioned this. This is a macro. So that way we can turn it off easily for certain build configurations. And that's just generally, even if you choose not to explicitly do a check like this and do some validation, I would still at least be aware of it. And that's kind of my point that I'm getting to. The fact that when you do have stuff like this, just be aware of what would happen if this was a different value to what I expected. Okay, then we have, so we could do high resolution clock now for some timing. We have a start time, and a previous time, which we update. So we basically time how long this takes, and we set our previous time to our end time, and then we begin again. And we use this, why? To calculate the difference between end time and previous time, which gives us our delta time in seconds. And then we multiply it by 1,000 to get into milliseconds. So this is just used for timing in the game. Very simple. It's just so that we know how much time has passed between loops, so that we can probably, in this case, just move the appropriate amount. It's interesting that this is happening, to be completely fair, in a console, in like a terminal engine, because I don't know what the refresh rate of terminals is, which means that we probably can't render more frames than the terminal necessarily allows, although of course I imagine that would be platform and terminal specific. So I'm then imagining that instead of rendering more frames, it might be used for timing. I mean, let's kind of drill down into here and we'll see what it's used for. Okay, so yeah, it's used for movement. Yeah, because I guess that makes sense. It's just, it might not render, but we still want to move it the right amount so that if it does have time, or if it does want to render more frames, it's got the ability to do that. And then inside this main loop, yeah, pretty simple. It's pretty much the same as any game engine, like just a normal graphical one with a window as well. Update input, so that goes into a static class over here. We've got some stuff depending on platform, so Windows and Linux over here as well. That's fine. And then we can also add listener functions. So this is a function we can add so that we can go through and, okay, so this is interesting. This is like an event system basically, where we can provide a custom Lambda, custom function that we want to be notified whenever a key is pressed. So if we had like a game class that wanted to respond to key inputs, we could just tell the input system in what looks like a static way to just basically, hey, ping me when a key is pressed, and that's how we can handle it. So that's nice. It's basically an event system. It's just, it's reduced to be input only, I think. I don't know if there is actually, yeah, there is event and there's an event dispatcher. So I'm wondering why that doesn't happen. And yeah, same situation, add listener, but there's a specific one for input specifically, which is interesting. I think I would probably try and combine the two just because, I mean, input events are events as well. So over here in the entry, we create a new shooter scene. It's clear that scenes here are the building blocks of our engine. If we take a look at entry point, which contains the engine, you can see that really the only data that we have to work with here. So if we actually collapse all this, The only data that we have to, by the way, there is actually a shortcut for that called Control MO, I say as I manually collapse everything. That's funny. The only data that we have to work with here is scenes. So inside a scene, what do we have then? Because the engine has scenes. What does the scene have? The scene has game objects in the form of a vector, a queue, and a map. The three amigos, the three brothers, the three musketeers, vector, queue, and map. So we got a capital G, we got a lowercase g, like I don't know what's going on with the naming conventions here, but either way, we have a vector of game objects, which I can only take to assume that these are the ones that are in the scene currently. These are the ones that are to be in the scene. So game objects to spawn. And then this is a name to game object map. It begs the question of why does this exist if you have a map? It is true that it is faster, or it probably will be, yes, it will be faster to iterate through a vector compared to like this tree that you have here. So that might be valid, and you just have pointers anyway. So you're not really duplicating, you're not really owning, there's no ownership going on here. I'm assuming the vector is in charge of owning it, and when you want to delete a game object, you delete it from vector. It's a little bit annoying though, that you have to manage two different data structures. So especially for what I can imagine is a terminal-based game. I'm not sure about performance there, but let's just say I feel like we have a lot of performance to use up, maybe, because it's not running that fast and there's no 3D CPU side management that we have to do if we had like a normal 3D graphics game, maybe with physics and with all this other stuff. So what I would say is I'd probably cut this out. I just have all the game objects here. That way you have a central place where they're all owned. Now, if we take a look at how game objects are made though, it looks like a game object itself has a transform, has a name, and has a vector of integers, which is its sprite. So that I'm assuming is the actual, like we had like a sprite, and we have components as well. So this is a component-based architecture. This is super annoying as well. The fact that some of these are just in the middle of the file. Some of these members are here. Like you gotta keep your members grouped. So if you want these to be public, because you can see they're under public, I would still 100% put them at the end, but just make another little public section and then put them here. This is optional, obviously, because this is already public, but it just adds a divider, and it obviously does nothing. So I do that usually. This is fairly standard, aside from the fact that the component is, just a vector. So it's not really quite an ECS, but again, I'm sure it's more than fine for this kind of terminal game engine. By the way, if there's anyone out there who's like making a super high performance like terminal game engine and who's like, no, we need the absolute fastest technology, let me know, because maybe I keep saying that you don't need that much performance for a terminal game engine, but maybe I'm wrong. This is probably what I have the biggest problem with. So we have a vector of a vector that is a sprite, and you can see that by default, it's set to this 1, 1, 1, 1 kind of sprite. So what I'm imagining is this is basically a sprite that looks like this. So we have 4 ones most likely arranged in this way. And the reason why we have a vector of vectors is because one of them will represent basically like the columns, and the other one will represent the rows. So these sprite elements in blue are stored basically inside this outer vector. So same thing for these ones. They're stored inside this outer one. So this, so to color code this better, this is the blue one and this is the green one. So the green one has 2 elements, and you can see the blue one also has 2 elements each. So why is this bad? This is seemingly a good way to store multi-dimensional, in this case, 2-dimensional data. The reason why is because by creating 2 vectors like this inside each other, you've created like an array of arrays. And generally speaking, arrays of arrays are bad news bears. It all comes down to one reason: memory. When you do something like this, as you can probably tell from this graphic maybe, the vectors inside have their own heap allocated memory. There's one green vector which holds 2 different vectors in it. And there's one that's over here, which holds the 2 integers. So 1 and 1 over here. And then there's another one, let's just put it over here, which holds another 2 integers. So that's the problem. If you look at this, what have we created? We've created a 1, 2, 3 different heap memory allocations in random spots in memory. So whenever we have to loop through this sprite, which I'm assuming is a lot because it's a sprite, so we have to render it every frame and possibly transform it or move it around as well. Whenever we have to do that, we have to look up all these different objects in memory. So if we take a look at where this is used as an example, we have this function over here called rotate sprite. The input here is all the integers of the sprite in that kind of multi-dimensional array. And then the output is also the same thing. And so what we have to do is we have to loop through the 2 dimensions like this, and then apply them back into this after we've done the transformation. That is technically a memory nightmare. That is very wasteful because we could do exactly the same thing with just a single dimension array. So what I'm talking about is you don't actually need to have 2 of these. You can just have 1 of them. And then if you're aware of the width of each row, then you can just basically be like, well, every 2 columns, every 2 indices, I'm going to jump a row down. So basically what I'm saying is instead of having 2 vectors with 2 integers each, we could have 1 vector with 4 integers. And so what that means is we just have a single contiguous buffer like this with 4 elements in it, rather than 1 buffer over here and 1 buffer over here, and also 1 buffer that stores the 2 buffers. So this is actually quite nice. It literally will reduce us from having 3 buffers in memory to 1. But what I would say as well is that if you want to go even a step further, what you can do is you can think about fixed width sprites. So fixed width, I really mean kind of fixed size. You could, if you wanted to, you could define a maximum size for sprites and then just have this be either pre-allocated ahead of time as like some scratch buffer or some persistent buffer. It could be something that's allocated somewhere within the renderer that just holds that. You could also treat this as a stack thing. So if you wanted to, you could have an array of integers, and let's just say your max size for a sprite was 9. You could always pass that around. I probably wouldn't recommend that necessarily over just having a pool of memory where you can grab these allocations from. So what I'm talking about specifically is we have a function like draw objects where we obviously have to go through everything, and you can see we're accessing that sprite vector in those 2 dimensions. We're going through like the X and the Y. We're accessing those 2 vectors for every like pixel, every integer inside that vector across all of the sprites, right? So this will go through, I mean, this looks like, this will draw a specific object. I don't like that it's called draw objects. It should be called draw object because we're passing in a specific object for it to draw. But outside of this, you can see we're going to go through every renderable game object, which has moved, by the way. That's cool. We're not drawing objects again that haven't moved. That's nice. And we clear the old one so we can kind of retain. So it's like almost like a retain mode UI or something. It's retaining, it's not changing pixels. Well, not really pixels, but coordinates or characters within the console that haven't changed. That's actually pretty cool. If it has moved and if it is renderable, then we're going to go ahead and draw that object. So we're basically like what we're doing really is we're trying to iterate through every single game object's sprite. So we might have like 10 game objects in the scene. Each one of them has a sprite. We need to iterate through every single sprite's integer that is inside these vectors for every sprite in our entire game world. So this is where my brain is now being like, okay, how do we optimize that memory access? Well, what if sprites were allocated from just one big, huge contiguous buffer? And every time you ask for a new sprite, it's like, how big do you want the sprite? Okay, a 2x2 sprite. Sure, here are 4 integers for you to use. And then, oh, how big is the next one? 3x3. Sure, here's 9 integers for you to use. And I'll obviously advance this. And what's the advantage there? The fact that this is going to be hot on the CPU cache. And when we do want to render it, when we do iterate through the whole thing, because we need to go and actually render those characters on the screen, we have it all in a contiguous buffer. So see, this is like the step up from what I was saying. Instead of just simply having a one-dimensional array like this, which is better than the 2-dimensional version, we can have a 1-dimensional array for every sprite. So instead of having a vector of integers for every game object to represent the sprites, you just have a single one for your whole game, for your whole engine that represents all of them. So that's really the next step up. And that's definitely something I consider based on the common use case, which here, like, we know we're going to render every single sprite. We have to. So therefore, let's think about how we can optimize the memory access there. All right, I hope you guys did enjoy this video and you learned something. If you did enjoy it, please don't forget to hit the like button. If you want me to review your code, send it in to chernoreview@gmail.com. There will be the email address in the description below, along with some instructions on what to include. If you want to do a bit of your own code reviewing using the power of AI, then definitely check out CodeRabbit using my link in the description below, and I will see you guys next time. Goodbye.